All right. So friends, you got a couple of minutes to take a look at this question. I want to make sure you understand it. So you've got a Prius, you've got a semi. We don't know what's going on. Somehow there's a collision. Collisions generally involve forces. The question is, which one, the Prius or the semi, which one experiences a greater force? Prius. Why do you say Prius? The Prius is smaller. Do you guys agree with that? It'd have to be a really small semi or a really big Prius otherwise. So the mass of the Prius is much less than the mass of the semi. Have you guys ever seen this thing? Like a less than sign, but it's like much less. So you write it double less than means much less. So the mass of the Prius is much less than the semi. And so your reasoning is, so talk to me a little bit more. What's going to happen to you? So the Prius experiences a greater force. Yeah? Because it has less mass. Okay. Do we have agreement there? Corroboration? Now, my question for you is, because this happens sometimes, that sometimes people don't pay attention. So I'm going to ask the question again. Do you guys agree with the assertion that the force that the Prius experiences, that's what you're arguing, right? The force of the Prius, so the force on the Prius is greater than the force on the semi. Do y'all agree, or do you have another assertion that you would like to make? I don't ask trick questions. I ask honest physics questions. Grace, you have your hand up a little bit. You think that they are the same force. The force on the Prius, so you're saying is equal to the force on the semi. So now we've got two assertions out there. What do y'all think? Do you agree with either of them, or do you want to flip it around again? Because we can do all three. Ed, what do you think? Okay, hold on. So I need to just write down what you said. So you said the phrase conservation of momentum. Do you guys believe in conservation of momentum? It's a thing. We've kind of showed that it's true. So conservation of momentum says, what did you say? Okay. So friends, this is the stuff that you need to be writing down. You definitely don't need your phones out right now. You definitely need your warm-up sheets out. Conservation of momentum, Ad is saying, means that the total momentum before has to equal the total momentum after. That's what you said, right? Did we say that that was true yesterday, I think? Like on that pink sheet? We also wrote it a different way too, didn't we? Did we also say that we could say that the change in momentum of the Prius was equal to the change in momentum for the semi? How are we doing? Okay, keep this going, friend. I did. Yeah?
It says that, like, when two objects interact, each exerts a force on each other, but they're equal, in just
Okay, so you're arguing for the green one as well? Did you say yeah as well, Ryan? Yeah. Or you? Okay, but one. Okay, so got you. Thank you. Oops. So like that. Now you think it's okay? So the magnitudes are the same. Okay. Can we get from what Ad said here about conservation of momentum to what you're saying here about Newton's third law? How do you get from the blue one to the green one? Is there a way to do that? How do you do it? I'm not going to call on you one more time because I want to make sure everybody's engaged. I want everybody's brains on, not just 2 or 3 people. How do you get from the green to the blue? Talk to your teammate. Talk right now. 30 seconds, go. How do you get there? Mass times. Did you get us there? All right, I don't know which table I'd ever call on because I feel like everybody's like, you always call on us. So I'm just gonna pick on number, I don't know, 12? Who's 12? Oh man, that means Luke gets to talk. Yes. Sorry, what did you guys say? You're okay, sweetheart. It's okay. It's okay. I didn't mean to. That was kind of unfair to put you on the spot like that. I apologize. Change in momentum is also known as what? It starts with an I. Impulse. Does that make sense? Change in momentum is impulse, which is also force times time, isn't it? Does that make sense, Luke? Where we're getting that from? So this is the force on P equals the force on S. How do the times compare? Same times? And if it's the same time, then what do we know about the forces? What'd you say? There's a negative in there. Silly negatives. I kind of forget the negatives sometimes, but there you go. Bam. Oops, whoa. It just disappeared on me. Oh, that's really weird. There you go. T's go away. Now, I want to say thank you to you two. Because the answer that you gave is my guess, the answer that every single person in this room would have given 2 days ago. And I want you to be really honest with yourself. And I'm not calling you out in a bad way. I'm just saying, think about it. If I had asked you 2 days ago, a semi and a Prius collide on a highway, which one applies a bigger force? Your gut feeling would say what? Which one's going to win? The semi's going to win, right? Whatever win means in physics. What does win mean? What's that? What does it mean to win in a collision? Okay, friends, we're coming back. Luce, what'd you say? To not be flattened, right? Bingo, it's true. Now, we're going to take the morbid stuff away, and we'll imagine that it's all on ice so that we're going to kind of bounce instead of crumple, because we don't. Inelastic collisions are a little dark, right, when you stick together and crumple and bad. But if you have, let's do an elastic collision. It seems like the semi is going to win and the Prius is going to lose. And you're not wrong. But here's the thing, is that it's not because of the force. This is the right one. What is it that you see the Prius do? If we've got an elastic collision, what does the Prius do? It stops, or it may even like bounce, like go the other way, right? Starts with an A. What's that A word? It's going to accelerate. Yeah. Let me show you a little demo. This is so nice because I've been telling you and trying to convince you for a while that this is what happens. But let me show you what actually is happening. So you guys have seen these carts before, right? You've seen these tracks before. I've got 2 carts. One's a Prius, one's a semi. Alex, I have a question for you. Which one's the Prius? The blue-green one. Why did you say? Yeah. We established earlier, right, that the mass of the Prius was a lot smaller. So this one doesn't have any weights on it. It's pretty light, whereas the gray one has weights. Oh, so it's much bigger. Okay. And then the other thing that we did besides just put weights on them was that we just put these little force sensors on. And so the nice thing about a force sensor is, I'm going to go ahead and collect some data that you can see up here. If I pull on this, you can see I'm applying a force. If I push, you can see I'm applying a force, right? So you can see those forces. Okay. And so I applied a force sensor to each one of the carts, and now we can watch the collisions happen. Okay. So I'm going to go ahead and collect some data, and we'll do a few different ones just to see. So I've got the Prius stopped at a stoplight, and the semi comes up from behind. Okay. Here we go. How do the forces compare? They're the same. One's positive, one's negative, but they're the same, right? What if we have it the other way? So we've got the Prius coming up, the semi's at rest. The Prius comes up from behind, not paying attention to the red light, not paying attention to the fact that there was an accident up there, and so everybody stopped on the highway, right? This is why you have to pay attention, right? Because here we go. If you're in the little Prius, you're going backwards. That thing's going to go forward. But what happened? Compare the forces. They're exactly the same. You with me there? Does that make sense? The forces are exactly the same. The acceleration or the change in velocity is different, but the forces are the same. We'll do a couple more just to see. We'll do a head-on collision because, why not? Right? It's bad. This one accelerated a lot. It doesn't matter how big or small the force is. I can even hold this one still. Oops, it didn't. It's not clicking. One second. Right? It does not matter. The forces are exactly the same in magnitude. See that? Every single time. How are we doing? We okay? Sweet. All right. We're going to move on to our pink sheet, that little half pink sheet. I'm going to give you just a moment, maybe 2 minutes, to take a look at the pink sheet with your partners, okay? We're going to discuss it in just a moment, so go ahead and do that. Take a look at that pink sheet. Oh, friends, I'm going to interrupt you for just a second because I want to say this before you get too far in. I don't want you to just say, oh, I know it. Oh, duh. I want you to be able to explain it. Because remember, at the end of the day today, we're going to have a quiz, a check-in, right? That's over this stuff. And if you just write duh on the answers, you're not going to get credit. So I want to make sure that you can stand behind your answer and use physics. I mean, like, if you're saying, like, they're the same, you're not just going to say they're the same. You have to tell me why. You have to explain using physics what's going on. All right, go ahead and do it. All right. So physics friends, let's have a conversation here. I hear a lot of people saying same, same, same. And I love that because I hope that what that means is that you're internalizing the concept. But I also don't want you to just say it without understanding it, without like having a good appreciation for it. Let's take a look at this first question here. We're not going to do all of it because it's kind of redundant, right? Would you agree? But let's take a look here. The tennis ball and racket force one. It says, a tennis player returns a serve. The physics student is watching the match and making the following contention. While the tennis ball is in contact with the tennis racket, the racket exerts a larger force on the tennis ball than the tennis ball does on the racket, because the racket has to stop the ball and reverse its motion. Is that physics student correct? No? Sam, did you agree with the physics student? No? No? Do you know why you didn't agree with him or her? Good answer, conservation of momentum. Now I will tell you that if you had this question on a quiz and you answered with that, and then you elaborated more to explain to me why that's a good, solid answer, that's correct. But if you just wrote, the student is wrong, conservation of momentum, no. But I'm going to tell you right now also that if you just wrote, the student is wrong, Newton's third law, I would also not give you credit. That was a good face right there. So, what? Why are you upset with me? She's like, maybe I kind of am, but I'm not going to admit it. Okay, let's talk it through. So the forces, are the forces the same or are they different? In magnitude. In magnitude, they're the same. So we should say that the force of the racket on the ball is equal to the force of the ball on the racket. We can say that this is true. We know that it's true because of what? Because of Newton's third law. But then you need to explain to me a little bit more. Tell me what you know, Or another alternative would be, why in the world would the student say that? Why in the world would the student have said that? Go ahead.
And the ball and the racket are touching the same amount of time.
Uh-huh.
So you'd be dividing the momentum by the same number, so your forces should be the same.
They should be, right? They should be. So we need to explain it a little more. Do you understand what we're saying? So you can use momentum, like Sam wanted to use. You can use Newton's third law, like we want to use here. But regardless, you need to explain it a little. You need to use the physics. Another thing that you could do to convince me as the grader that you do understand this would be to explain why the student may have thought this. I agree that the forces are the same. What is larger? What quantity is larger for the tennis ball as compared to the tennis racket? What'd you say? The acceleration is bigger. That makes sense? So if we say the forces are the same, hey, you guys remember that force is equal to mass times acceleration, right? So the mass of the ball times the acceleration of the ball has to equal the mass of the racket times the acceleration of the racket. But what do you know about the mass of the ball as compared to the mass of a tennis racket held by a person? Which one has more mass? What? Say it out loud. The racket. Racket held by a person have a whole lot more mass than the mass of the ball. So this one is much bigger, which means that the acceleration is going to be much larger for the ball. That would be another way to explain your answer, right? Is to kind of like talk through why they may have said that, even though it's not. You guys doing okay? I'm going to skip the second one. I'm hoping that you got it. I want to look at the back here real quick just to talk about maybe one of these, and then we're going to move on to the next activity. Okay? Two identical toy trucks are traveling at different constant speeds. Yeah. Where was that? At constant speeds about to collide. Trucks are traveling in the same direction. Which one's going to apply a bigger force? Did you guys have a chance to talk about this one? Ad doesn't get to answer the question because I feel like all of you are just waiting for them to answer. So I want you to talk about it right now. Turn it over. Look at those last three questions. I'm going to give you 1 day. And then I'm going to ask you for answers. You guys have to engage with this stuff or you're not going to get it. Go. Do you see some consistency in these questions? Yeah. Do you see a pattern? Perhaps. You guys don't? No, you don't agree? Okay. Okay. How do the forces compare? They're the same. Why do you know? Newton's third law. What does Newton's third law say?
When two objects interact, each exerts a force on the other. The forces are the same size and they are in opposite directions.
So that is correct. Now we were did that. She said yes. Now here's the thing, and this is
our notes though.
right. Here's the thing. This is the fine line. Okay. Not all questions are going to look like this. Not all questions are going to say that they have the same force. And this is my fear as a teacher. When you guys were in elementary school, did you have the opportunity to recite the Pledge of Allegiance? Did you guys have to do that when you were little?
No, we did till 8th grade.
Okay, so I want you to think for just a moment about when you were the littlest that you were when you got to that, whether that was in kindergarten or first grade or whatever, you stood up and you put your hand on your heart and you said a bunch of words. And did you have any idea what those words meant? Really? Oh, okay. So if you didn't have Sierra's mom to explain it, did you have any idea? Do you understand what I'm saying? I don't want you to just spit out words that you don't understand. I want you to show me on a quiz then in fact you do understand the physics behind it. Okay? I'll write questions so that you have that opportunity to show. All right. So the answer to all of those is the same, isn't it? And the answer is always because of Newton's third law. But again, I don't want you to just be like, Newton's third law, Newton's third law. Because that doesn't really show, that just shows me like that I learned how to answer this question. And that's not very much fun. What?
Yeah, it's better than mine.
Yes. Cool. All right. Right now, friends, we're not going to take our quiz yet. We have one more activity to do. So I need you to, here, I'm going to